Okay, let me start the recording now. So we have looked at how we can install a Kubernetes cluster. And so far, we saw that we could be able to install both a managed and a self-managed Kubernetes cluster. And the one we have installed so far, we have installed a managed Kubernetes, no, a self-managed Kubernetes cluster using kubeadm. So today, we are going to see how we can install Kubernetes using an infrastructure as a code software called KOPS. Okay, so this is infrastructure. Like when you are told about infrastructure, once you see all of that, it's just about you being able to either create an infrastructure. Now, when we install our first Kubernetes cluster using KOPS, we achieve this overall process manually in the sense that we were able to go to this Kubernetes, to our AWS cloud account, and we installed all the machines that we needed, both the master and the worker machines. Then we had to now install the required software, including kubeadm. And after we did all the installation, we initialized the control plane. We initialized the master machine using the command kubeadm init. Now, all of that was a manual process. And it is important to note that what we did using AWS, we could have as well used our VirtualBox, that is VMware. We could as well have created servers in CentOS and achieved the same thing. You see that? So what we did, it is, we call that a self-managed Kubernetes cluster because, we were tasked to manage our control plane. And, we realized there were some limitations in this self-managed Kubernetes cluster. And we are going to see those limitations, more importantly, as we try to install Kubernetes using other softwares or Kubernetes using managed, options. So now, today we'll look at KOPS. And what is KOPS? KOPS, Kubernetes KOPS is a software, which we can use, to set up highly available production-ready Kubernetes cluster. That is what KOPS is all about. So take note about that. So KOPS is a software. You see that? KOPS is a software. So we are going to be installing this KOPS software. But as we said again, when we are setting up a Kubernetes cluster using KOPS, what we are basically doing is we have to install the KOPS software. Now, once we install that software, we are going to use the software to automate the process of creating, our Kubernetes cluster, which implies once that software is installed on whatever server we want to use to create a Kubernetes cluster, we'll just execute some commands, and that command is going to create this Kubernetes cluster, in our AWS account. Now, the KOPS software can be used equally in other cloud platforms like, Google, Azure for Microsoft. But as we all know, our project, we are using AWS as our cloud provider. So that is one thing that we are going to be able to achieve today. Now, the question now is, how can we be able to communicate, with this AWS account to create resources? And what are the kind of resources that we are going to be able to create? Now, for us to communicate with AWS account, we need to install the AWS command line interface, the same way we installed kubectl. So we are going to install AWS CLI command line interface, where we can interact with this AWS account using commands, not just coming here to create EC2 instances. So please take note, very important we have that understanding. So now, we are going to execute all these commands you see here to create our AWS command line interface. Now, once this interface is created, the next thing is for us to create, our Corp software. So we are going to install this software. And today we are going to do that installation on an Ubuntu instance. So we'll execute these commands, okay, to be able to install Corps. Now, once Corps is installed, since we are trying to create a Kubernetes cluster, we are going to install kubectl so that we can be able to communicate with the API, with the API server. So please take note. So we are going to install kubectl. Okay, we'll use kubectl to communicate with the API server. Now, very important. We want to use this Corp software to create resources in AWS. For that to happen, now we need to assign some permissions. So we are going to assign some permissions. So how do we assign that permission? We will create an IAM role, Identity Access Management role, okay, from our AWS console or CLI. Now, when we create this role, what are the policies we are going to attach to this role? These are the policies. We are going to tell the role, we are going to give the role what we call EC2 full access, which implies now Corps is going to be able to create EC2 machine. So it needs access to create EC2 machine. Now, we are going to, once we create this EC2, okay, once we create our Kubernetes cluster, now, for us to be able to gain persistent, okay, volume, we are going to create a storage class in S3 bucket. So for us to do that, we need to be able to create an S3 bucket. So for that S3 bucket to be created, okay, we are going to grant Amazon S3 full access to this IAM role. The next thing is IAM full access and VPC full access so that we can create the required resources. So please take note. These are all these stages for us to be able to achieve that. Create an S3 bucket. Okay, so we now, once we have assigned this particular options here, these rows, we cannot be able to create an S3 bucket with this command. AWS S3 MB means make bucket. So we can make a bucket of this nature, whatever name. But now, for one thing you should notice that this particular AWS resource S3, your bucket name must be globally unique, which means no other person should have the same S3 bucket with you in their own accounts. So take note. So we are going to have something like, nubonglega.k8.local, whatever, but it must end with .local. Now, the next thing we are going to do, the next thing we are going to do is, to create some environmental variables and expose them. So we are going to get into this file called .bash, RC, and whatever S3 bucket we had created is going to come here, Corp state store. So this is going to be able to store the state of our stateful applications. Like, if we want to create a database and stuff, that's what we are going to be able to achieve. The next stage is we are going to create an SSH key. The purpose why we are creating this SSH key, is to establish communication between the Corp server and the Kubernetes cluster. Because we are going to create an independent Corp server and we'll use that server to communicate with our cluster. So we will need some keys as well to establish that communication. So we'll create SSH key, and we are going to transfer that key as a secret. So it's going to live from the Corp server to all the servers that we are going to create. So please take note. And this is the command now to create your cluster, Corps create cluster. Where do you want to create the cluster? The zone. Which network do you want to use? Network, we have seen the Wave network, the Weave network. We'll use it again. Now, the machine sizes, -- master machine. We have T2 medium. Now, we have worker machine node. We have T2 large. How many worker node do we want? If we want 2, we are going to, okay, state it here. If we want 3. Now, this dollar name, we are going to understand where this dollar name is coming from. But this dollar name here, let me show you something. We have dollar name. Okay, now look at something. When we are trying to add these environmental variables, we are saying export name. You see this name? This name, okay, we are trying to give the name of our cluster. What is the cluster name that do we want to give? Export name. That information has, let me just do a little bit of modification and commit it because you, now export name, create cluster. Let me go to export name. This name should not have S3. So the name is going to be something like this. K8S. Take note the name. This is the standard practice. Kubernetes is K8X. So the name, now I have defined these environmental variables. And I'm calling my cluster name is, for example, I can call this cluster, let me just call it class 21. That's going to be the name of my cluster, class 21. My S3 bucket, I can call that S3 bucket as well, class 21. K8s.local. This is my S3 bucket. So when I want to create this bucket, it's going to be class 21, K8s.local. Let me come here. Make bucket S3, class 21, K8s.local. I hope there is no, anyway, if there is any, it's going to tell us and we can always change it. So with that now, we are going to create our cluster. So once we are creating this cluster, what are we referring? We are referring to this name, KOPS create cluster, okay, dollar name. So the name that we define in our environmental variables, that is the cluster name that is being created. And this S3 bucket is going to be created, we are going to create this S3 bucket via command line interface. So now, if you look at something here, I'm trying to create T2, let me see, what do I have here? I have T2 large. I'm going to do T2 medium. Okay, or large is okay because we are going to use this cluster to create, to deploy Grafana, which is very heavy, to deploy Ileke, which is very heavy as well. So this dollar name here is going to be calling for that variables. We saw this variable when we did, so when we did share scripting, we saw how to call variables. So now we are going to create our secret. We are creating a secret for dollar name, Kubernetes cluster. You see that admin. So this SSH public key is going to be copied. Okay, so take note about that. We are going to see how to achieve all of that. So KOPS update cluster, dollar name or cluster name, no need, just call the variables -- yes. Then validate cluster, kubectl get node. So whatever you have validated, you are going to be able to get the information. And if you want to delete this entire infrastructure, KOPS delete cluster, this is the command. You see that we are going to call, we are deleting this cluster, okay, and the S3 bucket, KOPS state store is going to delete everything. Now, so this is one thing that I wanted us to have an understanding on. So that's it. One thing again we should know is, as far as KOPS is concerned, KOPS is a software which we can use that software to create production-ready Kubernetes cluster. So please take note. I think I should just add that particular definition in this repository. I'll share it with you guys. KOPS, setting up Kubernetes cluster on AWS using KOPS. Now, this is README note. So KOPS is a software used to create production-ready Kubernetes cluster in a cloud provider. Take notes, in a cloud provider like AWS. So this is all about KOPS. KOPS is a software used to create production-ready Kubernetes cluster in a cloud provider like AWS. You see that? That's what KOPS is all about. Now, let me just illustrate.
Sorry, the email address you have on that page is wrong. It's not, there's a typo there as well.
Okay, this, okay,
yes.
I get it. Okay, that's okay. .gmail.com, so that's fine. So we have, this is KOPS. KOPS is a software used to create production-ready Kubernetes cluster in AWS, okay, in cloud providers like AWS. That is KOPS. Now, what is KOPS going to create? What is it that KOPS create? Okay, what does KOPS create? Let me see. This is a cloud provider. This is a cloud provider. We have this cloud provider. Now, this is cloud provider. Let me just so we get it clearly. This is a cloud provider. I want to show you guys what happens, what KOPS is going to do. Now, so inside this cloud provider, KOPS is going to create a control plane. Okay, so it's going to create, how do we call control plane again? That's master. It's going to create control plane and worker nodes. This is infrastructure automation using KOPS. Infrastructure automation using KOPS. It's going to create worker. Now, and there's something that KOPS is going to do in addition. Now, so KOPS is creating these resources. In addition, KOPS is also creating an S3 bucket. You see that? KOPS is going to create this S3 bucket. S3, still within the AWS, this is what KOPS is creating. Now, so we are going to have KOPS here. This is KOPS inside AWS Cloud. You see that this is KOPS. So we are going to install KOPS, install AWS CLI, install kubectl. So very important, KOPS. We're going to install KOPS. Come here. Install KOPS. The next thing is we're going to install AWS CLI. We are going to install kubectl. We are going to do the kubeconfig file, because for this machine to communicate with this control plane, it's going to need this kubeconfig file, because this is now, it's trying to access this, okay, this particular control plane externally, and we need SSH key for secret to create the secret. You see that? So this is what KOPS is going to need to communicate with this particular Kubernetes cluster. But there is something KOPS is going to do, okay, which is very unique. Now, what KOPS is going to do is, KOPS is able to replace this. For example, if for any reason, any of this worker saver goes down, right, KOPS is going to recreate the saver. So KOPS is going to maintain the state of this cluster. You remember what happened with a level of the control plane where our controllers, right, controllers could maintain the state of pod. If any pod goes down, the controller, like replication controller, replica set, deployment, they are going to, daemon set, they are going to recreate the pod. That's what happens. So KOPS is able to replace this saver just in case anything went wrong. Big question. How will KOPS achieve that? What is it that KOPS is going to be able to create in addition that will permit KOPS, okay, to replace these machines? Who can suggest an answer? What is going to permit KOPS to replace this machine? Now, KOPS is going to create what we call in AWS auto-scaling group. You see that? So KOPS is going to create auto-scaling group. So with this auto-scaling group, okay, there's going to be some launch configurations, launch configuration as well. So KOPS is going to create auto-scaling group and launch configuration. That's what KOPS is going to launch. Let me come configuration. Launch configuration. Now, this is what KOPS is going to do. It's going to create launch configuration for our master and worker. It's important we take note of that. So this is what KOPS is going to be able to achieve. Therefore, now, via these KOPS, once we have installed KOPS, we will now use KOPS to automate the creation of these resources. So it's going to create all these resources at once, everything here. So please take note about that. Now, what is the importance of a launch configuration? This launch configuration is going to contain some templates. Like the template, is going to have template for the master machine, so that if master machine goes down, okay, auto scaling group will use this launch configuration to recreate the master machine. You see that? So it's going to use that template. What is the template for the worker? What is the template? Because if it's going to recreate this machine to join this cluster in the fly, all of that is going to happen with zero downtime. KOPS will need what we call launch configuration, okay, for both the master machine if it goes down, because KOPS can create any number of master that we want, any number of master machines or worker machine that we want. So that's it. Let me just come to this, our KOPS installation. I'm trying to equally automate the entire process. Let me see if this process can be automated. Now, this is KOPS. I want to see if we can automate this process. You see that? Because by now, I've already explained to us what the commands are going to achieve. So automating the process is important. So what is going to be the name of our, so now one thing again, let me come here. In trying to automate, let me commit these changes. We did some changes. Let me commit it in our GitHub repository. Now, I come here. I want to automate the process. So I'm going to create, this is the S3 bucket we are creating. This is the S3 bucket we are creating. AWS make buckets. This is the S3 bucket we are creating. So let me just copy this line. Make buckets. KOPS installation. Okay. Now, this is our installation script. This is a multi-line comment. You can see that, right? KOPS. This is a multi-line comment. So it does not have any impact there. So let me comment this other line, comment, so that Control V, setting up Kubernetes cluster using Corp. So this is where the script is going to start. Bin bash, install AWS CLI. So we have all of that is going to install the CLI. Now we'll come here, install kubectl. Once we have installed kubectl, we can use this command to make bucket. So let me come here, AWS make bucket. Let me do Control V. The name of our bucket is going to be called class 21. That's our bucket name. Class 21. I want to make this bucket. No, class 21. KAS.local. Now, one thing I want to let you know is for the name of your cluster, if you omit K8s.local, that is whatever name you want to use, if you omit it, the cluster will not be validated. So take note about that. So what I'm going to do here is we are going to run this command, okay, up to stage 4. You see that? Up to stage 4, we are going to run the command. Now, let me come here, set environmental variables. So up to stage 4, we'll execute the command. Control V. So I'm copying the commands that can be automated. So I come here, right up to where I can make bucket and list. So now, before doing that, let me come back to my AWS cloud. Let's see if we can convert this saver to a Corp saver. This is our HR proxy. We could convert it to a Corp saver. You see that this HR proxy saver, we can convert it to a Corp saver. So why I'm going to shut down all these others, these self-managed savers. I'm shutting them down. I won't need them. Action, instance state. I'm terminating these self-managed clusters. I'm terminating all the instances terminated. I won't terminate this other guy because I will just add here corps, change all those things to corps. That's going to be my corp saver. Let me see, did it change or not? Okay. Let me just add corps. Corps. Okay, so now I've added corps. What's happening? I'm adding corps. Corps. Okay, now I've added corps to this server. So let me log into this server, connect into it. Now, before connecting into this server, let's go. So what you would do is, look at what we are going to do here. Now, we have this server. We want to use this server to create resources in AWS. So I'm going to go to my IAM under services. We are going to do this next week again. IAM, we'll be looking at AWS. So one of the services we'll look at is IAM. Now, for IAM, I want to create IAM roles. So I'm going to come here to roles. I want to create a role. I'm going to call that role corps. I think I have a corps role, which I created before, but let me just create one again. Let me do corps underscore K8 underscore role. That is the name of the role which I'm creating, create role. We have created that role. Okay, so now I have to assign, okay, permissions to that role. So let me go to next, permissions. I want to assign permissions to the role. Now, the permissions I want to assign is EC2 full access. You see that EC2 full access, I'm going to select it. The next permission, S3 full access. Okay, I need S3 full access. I also need IAM full access. The last thing I need is VPC, Virtual Private Cloud full access. So now I've assigned, okay, so what we have done is we are creating an IAM role and assigning policies or permissions. What can this role do? So I go next, no need for a tag. You see that role name. I thought I gave the name already. Since I did not save that name, let me give it again. Corps. I'll just call that role corps, okay? Corps. So that is the name of the role. You see that corps, create role. So we have created a role. The role has been created, corps role. I click on it. It has 4 permissions. So this role can create EC2 machines. It has full IAM access, IAM, so it can assign other roles. It can create S3 bucket. It can create virtual private cloud. You see that? So this is the role. So what I'm going to do is I'll go back to my corps machine, to my corps saver. I come to this corps saver. Now look at something. Before connecting to this saver, I'll click on this saver. I'm going to come here, instance settings. I go to instance settings, modify IAM role. I click on it. Now, I can attach an IAM role. I have this KOPS IAM role, so I can attach it to this EC2 instance. You see that? Now that I have attached this IAM role to this instance, okay, this instance can perform everything that role specifies. So let's connect to the instance now. I'm connecting to it. So come here. Whatever this instance specifies, it can be achieved. So let me play the screen. So now we are trying to access this instance using the role. So I'm going to using SSH keys. So we come here. Let me get into the instance. We are inside this instance. kubectl. Let me check if we don't have any kubectl in this instance. So, but we have to install kubectl. We have to install all the softwares that we indicated. So I come back here. I want all this command to be executed up to this point. So I copy all of this. I want to automate the process. So I'm going to vi into corps.sh. Okay, corps.sh. So now creating corps. So you see this is multi-line comment. You know, we saw. So now it's going to install our AWS CLI. It's going to install. Now for you to install AWS CLI need Python. Okay, remember when we're trying to install applications like Maven, we needed Java. For AWS CLI for you to run any AWS command, you need Python. If you don't have Python, you can't do that. So that's why you see the install Python. So you're going to do apt-get install on zip and Python. So it's going to install AWS CLI and all its dependencies. So let me save and quit. And it's going to be able to create a bucket. For example, if I do AWS now, it tells me command not found. You see that why? Because we have not yet installed AWS CLI. So we can achieve that by automating the process. We do sh corps.sh, enter. It's creating those resources, downloading. We are automating the entire process. So now, while we are here, let me just come here and show us something. This AWS dashboard. Now, in this AWS dashboard, what do we have here? Let's come to auto scaling group and check if we have any auto scaling group available at the moment. Do we have any? We don't. Let me minimize. Do we have any auto scaling group here? We don't have any auto scaling group. Now, we expect Corp software to install, that is to create an auto scaling group, okay, for both the worker and master, and to create launch configuration. We don't have any launch configuration. It will also create a load balancer. Let me check if we have any load balancer. For now, we don't have any. So take note, we are going to use this North Virginia region to achieve that. North Virginia region is US 1 East. So we'll use US 1 East. US 1 East. Let me see, our KOPS machine is on. This is T2 micro. This KOPS, we may have to change, we may have to do a vertical scaling on this server. This T2 micro. So US 1 East A. So I come back here. So look at something. It has created make bucket. Did it create the bucket? Did it create the bucket? How do we know if it has? Remember, the commands that we executed, the last command, okay, is to create a bucket, AWS make bucket. It has to create this bucket. AWS S3 make bucket name, class 21 K8s.local. So if we execute this command, AWS S3 ls is going to list all the bucket all the S3 buckets that is available on. You see that? So these are the buckets that I have currently. I have this bucket. These ones have been created in my AWS account. So if I come to this AWS account under services, if I type S3 under services, we are going to see class 21.k8s.local. This is the bucket that it has created. That's my S3 bucket. Now, we have this bucket available. We have this bucket available. So what are we going to do next? Let me take us back to our installation guide. Now, we had already achieved step 5. We created an IMN role with all these policies. We attached the role to the KOPS saver. We had to attach that role to the KOPS saver, which we did. We have created the S3 bucket. The next thing we have to do is to set the environmental variables. So we are going to VI into bash.rc and copy all of this, bash.rc. So now we can, let's VI sudo vi .bash. Okay, the file name is called .bashrc. So this is us in that file. You see that this is us in that file. Let me see some. Let me try to go back to the other. Let me VI without sudo and see the difference. Okay, it's the same thing. Bash.rc. So now we want to enter the environmental variables. So I'll just enter it here. I'll enter it here. I'm setting up environmental variables. Let me come back. Environmental variables, trying to set that up. VI into bash.rc and enter these environmental variables. And note that you cannot use class 21 on your AWS server. That will not work, because if you want to create, okay, your S3 bucket, if you use class 21, it's going to tell you that that bucket is already available. So you are going to use something else. Maybe you can do class 21, Frida, class 21, Henry, whatever you want to do. So take note about that. So I come here now. So now I'm trying to set this to define this environmental variable. The name of my Kubernetes cluster is class 21 K8s.local. Now this is the S3 bucket I already created. Class 21 K8s.local as well. So once I do that, I'm going to refresh this file by running the command source. We have seen that before. I refresh the file. Okay, the file is refreshed. So with this now, we are going to create our cluster. But before doing that, we'll execute this command SSH keygen to create the cluster secret that we can use to establish communication. So SSH keygen, I'm creating an SSH keygen. So the key has been created. So what do I do next? After creating that key, I can now create my cluster. Now, we are going to create our cluster in US East, okay, 1A. That's what we are going to do, US East 1A. So I'm going to come here, US East 1A. 1A is Virginia. Let me just show you guys. So look at what we are trying to do. We are creating our cluster in US East 1A, which is not Virginia. Take note, US East, that's it there. Availability zone 1A. So I come back to the cluster. So I'm going to create a cluster in US East 1A. So take note, I can copy all of this command to create that cluster. Let me come here.
But if I have my servers in Canada Central, I can create
Yes, you are going to just, you can create them wherever you want to create. I'm using,
Okay, thank you.
you're welcome. I'm using US East 1A to create the cluster. So this is the command: KOPS create cluster -- zone US East 1A. Now, network that is going to use for Q proxy is the wave network. Now, the master server is going to be T2 medium. How many master server do I want? I can decide to put here 3 masters. I can put any number of worker that I want, but for this example, we'll just create 1 master and 2 worker. We are using T2 large because we have to install a lot of applications, okay, in this particular T2, this worker node. So let's go back now. I execute this command. Cluster create. You see that? It's creating the cluster. The cluster has been created. Finally configured your cluster, KOPS. You see that? So now I'm going to run another command to share the secret that I created with my SSH key. Take note, this secret, KOPS create secret. Okay, I'm creating a secret for my cluster name. Okay, so there's going to be this admin user. So I can log into this server, into this cluster via this admin user. So that's what I'm trying to achieve there. So that's it. So I come here, just execute this command. KOPS create secret. Okay, secret created. Next command, we have to validate the cluster. So create Kubernetes cluster, KOPS update cluster. Once it is updated, it has to be validated. So we do KOPS update cluster. Now, KOPS update cluster, $name, -- yes, no need. Okay. You see that it's creating the cluster now. Look at what it's creating. etcd for client API server, etcd, okay, manager, kubelet, kube proxy, whatever I need to create. Do you see that? It is creating that particular, all those resources. It is telling me that now validate cluster KOPS validate. So I can do KOPS validate cluster, but I have to wait for a while. Cluster is starting. It should be ready in a few minutes. You see that? That's what I'm told. Cluster is starting. Okay. It should be ready in a few minutes. So if I try to validate, I'm going to get an error. So if I run this command, KOPS validate cluster, it will give me an error. Now, this error is because it is still validating the resources are still being created. Validating cluster, the resources are still being created. You see that API server, master, whatever it needs to create is being. So if we go to our AWS account, let me see if we have the resources being created now. Let me refresh this page. Now, did you see that? Did we create these instances? We did not. Now, this is infrastructure automation. So KOPS is creating these instances for us. Now, let's see what else KOPS is going to create. Let's come here to auto scaling group. Now, it has created 2 auto scaling group, one for master, one for worker. You see that? So and it is saying that the desired state of instances is 1. Okay, the instances that are running at 1, the desired state is 1. So the minimum is 1, the maximum is 1. You see that? So, so this is what we have here. Okay, so now I could decide to maybe, modify this desired state and probably say that, let the maximum be 5 and the minimum be 2. It's going to just create the resources automatic. Now, this is auto-scaling group being created. So at any point in time T, this auto-scaling group will ensure that we have the required number of servers available. But the question now is, if a server goes down for any reason, how will this auto-scaling group how will it replace the server? It will replace the server using launch configuration. So if I come back here, okay, I have what we call launch configuration. Launch configuration. This is launch configuration. So in my launch configuration, okay, I have a launch configuration for the master and the worker node. So if I come here to master, it has some, look at something. It has some user data. We did not create this user data. View user data. You see that? This is the user data. So this user data is the template. If anything goes wrong, it's going to use this user data to replace the master machine using this launch configuration. So this user data has the template. It's going to do everything. Similarly for the worker. The worker has user data as well. You see that anything goes wrong with the worker, it's going to replace it. So this is one thing that we have to take specific note of. We have to take specific note of. So now, let's check if our cluster is ready. Okay, our cluster is ready. kubectl validate. I have, okay. So our cluster is ready. But we still have like a kube system pending. Some resources are still being, okay, it's yet to join. The machines are yet to join. So if I do kubectl get note, now for now we have just the master server. We have just the master. Okay, so when I did kubectl validate, it's telling me that these worker nodes are yet to join. Let me try it again. Now they are trying to join, but not yet ready. You see that they are not yet ready. So this is, creating kubectl get node. Okay, one node has joined. The other one is not yet ready.
Hello, Prof. Just a quick question here.
Yes.
With the corps, is there any downtime in regards to the recreation of a server? Is there any downtime?
There is a downtime. The downtime is next to 0 because, for example, now we have all these nodes ready. Did you see that? Everything is ready. So if I come here, assuming we decided to, let's just go to our EC2, this EC2. Now we are using these Corp servers to communicate with these nodes here. So if I come to this EC2, this is a worker machine. I'm going to terminate this worker machine. Normally, right, in the launch configuration, what happens is, if for a new server to be recreated, it's going to check the health, it's going to do a health check. Let me come here to instance state, terminating. I'm terminating this machine. Okay, it's been terminated. This manual termination, it has been terminated. Immediately it is terminated, a new machine. So what happens is that now it's going to do a health check. You see that? Get note. It's going to do a health check. So the auto scaling group will do a health check and probably, if any of this machine is not available for a specific time, maybe 5 minutes, it's going to recreate the machine because something could happen and it can't communicate. So they'll normally define a time and say, okay, if after 5 minutes you can't access this particular server, we create the server. You see that? So let me see something here. Now it tells me that not ready. Why? Because we have shut down this server. The server is shut down. You see that? So very soon, this server is going to be replaced. So if I go back, not ready, it's still shutting down. This, okay, so it is still shutting down. This node is still shutting down. It's going to take a while. Okay, see not ready state. And look at something. This server, the IP address ends with 149. Did you see this? It ends with 149. So we have 172.2.44-149. That's the IP address of the server. Not ready. 149. So it's going to take a while, and it's going to replace the server using the launch configuration and the auto scaling group. That's what happens. It's actually C shutting down. It's a T2 large server. It's a T2 large server, so it has a lot of resources. Okay, now it's terminated. That server is fully terminated. Okay, look at, did you realize that it is recreating one more server? Did you realize that? Did you see this initializing? So now one more server is being created. It's initializing. So we do kubectl get node. Now there are two nodes. This other node is completely taken out. Okay, shortly. Okay, so now this is, what KOPS is going to enable us to achieve. And for you to say in any interview that you have installed Kubernetes using kubeadm, using KOPS, okay, that, it has a, it's a big deal. So take note about that. And that's what we have achieved this evening. We have been able to install our Kubernetes cluster using what? KOPS software. So KOPS has installed a production-ready Kubernetes cluster. Okay, so what we can achieve with KOPS is what we are going to be doing now. Because for us to do real deployments, we are going to need, servers that can be able to support such deployments. Yeah. Let me come back here and let's see Kubernetes plus. Okay, the third node is there now, not ready. So normally, what is going to enable this node to get ready is the user data. The user data is going to ensure that everything, all the configuration is available for this Kubernetes cluster to be able to join. So let me just share this. I'm going to share this URL with you guys now. So you can use just this GitHub repository for this installation. Is it okay? This GitHub repository is sufficient. So let me just modify some of the stuff that we did. GitHub repository. We have selected a role. We have saved class 21. Make buckets. Cube. What did I do? Yeah, example. We have set our environmental variables. Okay. So this is, I'm sharing this URL with you people now. So now this is what we needed to understand in the first part of this class today to be able to install a Kubernetes cluster using KOPS. So if you check your note, if you check our class channel, I've shared this URL with you guys. So that's what KOPS is all about. KOPS has created launch configuration, auto scaling group. Okay. we have used secrets to be able to communicate. So please take note, it's very important we have that understanding. I'm going to stop this. Okay.